Okay, so here I got two right triangles. Now I know I didn't write it very perfectly, but that's fine. And they have this right angle in common, and they have this angle theta in common. Okay, we're going to call this angle theta. That means that if two triangles have the same angles in two angles in common, they're going to have a third angle in common, because all triangles have to add up to 180 degrees. The angles have to add up to 180 degrees, and this angle will be equal to 180 minus 90 plus theta, but that would just be the same thing as saying 90 minus theta, because theta 180 is 90 divided by 2. 90 plus 90. Since we already got 90 right here, it'll just be 90 minus theta. So this angle would be 90 minus theta, and this angle also be 90 minus theta. Ow! And we know that if they have all three angles in common, then you have similar triangles. And what that means is that their sides, the ratios of their sides, will be the same. The ratios of their sides will be the same. Meaning that if we were to take the ratio between AC, let's say we're looking at theta. We're going to look at theta. We'll take the ratio of ABC or BC over AB, or this side that's opposite to theta, which is BC over the hypotenuse, or AB. That's going to be equal to taking the ratio between EF, or the opposite side to this theta, EF over this hypotenuse, DE. That's going to be equal to each other because they have all the angles in common. And it'll be the same thing if you were to take, let's say, this side, AC, over the AB, the hypotenuse. So if we were to take AC, ratio between AC, which we'll call the adjacent because it's right next, well, you just call it the adjacent actually, because it's right next to theta, over AB. Oh wait, did I write AC here? I meant AB. Sorry, my bad. I meant AB, not AC. So right here, AC over AB is going to be equal to DF over DE. And the same thing will be true if we were to take BC over AC. If we were to take BC over AC, that's going to be equal to EF over DF. So what I'm saying is that whenever you take, actually, let me just write the names for these sides. Adjacent and hypotenuse and hypotenuse. So whenever you take the ratios between, when you have two similar triangles, triangles with all three angles in common, you take the ratios between their sides. I mean, the ratios will come out to being exactly the same. They'll be all the same because they have the same angles in common. And this is a very important concept in trigonometry, so much that they gave this idea their own names. They said, well, if you we're going to call these, start using these as opposite and adjacent and hypotenuse and the sides and everything. If you were to take the ratio between the opposite over the hypotenuse, the opposite side over the hypotenuse side, we're going to call that sine of theta, because they use theta to recognize which is the opposite and which is the hypotenuse and which one's adjacent and everything. So relative to this sine of theta, to this sine of theta, to this theta, you'll get opposite over hypotenuse, and that's called sine. That's called sine. Having the opposite over the hypotenuse is called sine. Having this AC over AB, AC over AB, which is adjacent over hypotenuse. This is adjacent over hypotenuse. That's called cosine. Cosine of theta. Or cos, as most people put. Cosine of theta. Cosine of theta is equal to adjacent over the hypotenuse. The ratio between the adjacent side over the hypotenuse. And what we call the BC over AC, BC over AC, which is opposite over hypotenuse, opposite over, not hypotenuse, it's adjacent, opposite over adjacent, the opposite side over the adjacent side, we call that tangent of theta. The tangent of theta, that's what that ratio is called. It's called the tangent of theta. And oftentimes it can be difficult to remember which one corresponds with which, like which does adjacent over hypotenuse correspond, cosine, sine, or tangent. So we have this acronym called for this one it's called, it's called SOHCAHTOA. SOHO, which means sine, this means sine, the S means sine, the O means opposite, and the H means hypotenuse. So, and then we have ka, which is C is cosine, A is adjacent, and H is hypotenuse. And then we have TOA, and T is tangent, O is opposite, and A is adjacent. So if you're able to memorize that, you say SOHCAHTOA. Sine is for opposite over hypotenuse. Ka is for cosine, adjacent over hypotenuse. And TOA is opposite over, tan is TOA, which is opposite over hypotenuse. SOHCAHTOA. And we're going to talk about it again more in other videos, but yeah, sounds cool.